Hello everyone, this is Vikas. I'm going to talk about physics topic, which is using quantum technologies to improve fiber optics communication systems. I am from CSC Data Science Department with a rule number bearing with the rule number of 22951 A67H naught. Now, after that, let's go to what is the outline and what are we going to discuss in this PPT. Number one, overview of fiber optic communication systems. Number two, what are quantum technologies? This is like question and we'll get the answer of that question from this slides. How can quantum technologies improve fiber optic communication? Quantum key distribution, quantum entanglement and quantum teleportation, quantum repeaters, quantum memory, quantum noise, and error correction. And the last will be concluding this PPT about using quantum technologies to improve fiber optic communication systems. Now, first, let's go into the introduction of the topic. Introduction. Fiber optic communication systems have revolutionized the way we transmit information over long distances. However, as demanded, faster and more secure communication grows. Traditional fiber optic systems are reaching their limits. That's where quantum technologies come in. By harnessing the weird and wonderful properties of quantum mechanics, we can improve the speed, security, and distance of fiber optic communication. Overview of fiber optic communication systems. Before we dive into the world of quantum technologies, let's first review the basics of fiber optic communication systems. At their core, the systems use pulses of light to transmit information along thin fibers made of glass or plastic. The light bounces off the walls of the fiber, carrying the information encoded in the pattern of pulse. Fiber optic systems offer many advantages over traditional copper wire communication, including higher bandwidth, lower signal loss, and immunity to electromagnetic interference. They are used in everything from internet cables to medical equipment to military communications. What are quantum technologies? Quantum technologies are a set of technologies that harness the principles of quantum mechanics to perform tasks that are impossible or difficult with classical technologies. Quantum mechanics is a branch of physics that describes the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. Quantum technologies take advantage of phenomena such as superposition, entanglement, and tunneling to perform tasks like computing, sensing, and communication. Unlike classical technologies, which operate on binary bytes of information, either on 1 or 2, or 0 or 1, quantum technologies use quantum bits, qubits, which can be in multiple states simultaneously. How can quantum technology improve fiber optic communication? So, how exactly can quantum technologies improve fiber optic communication systems? One major area is in encryption. Traditional encryption methods rely on mathematical algorithms that can be broken with enough computing power. Quantum key distribution, on the other hand, uses the principles of quantum mechanics to create unbreakable codes that cannot be intercepted without detection. Another area where quantum technologies can help is in extending the distance over which fiber optic communication can operate. As light travels through the fiber, it gradually loses energy and becomes weaker. Quantum repeaters can be used to amplify the signal without promising its security, allowing for longer distances between communication endpoints. Till now, let's see what we have discussed. We have completed overview of fiber optic communication systems. What are quantum technologies? How can quantum technologies improve fiber optic communication? Quantum key distributions. We have discussed introduction, overview of fiber optics, communication systems, what are quantum technologies, and how can quantum technologies improve fiber optic communication. Now let's see how can quantum technologies improve fiber optic communication. So how exactly can quantum technologies improve fiber optic communication systems? One major area is encryption. Traditional encryption methods rely on mathematical algorithms that can be broken with improve computing. Quantum key distribution, on other hand, uses the principles of quantum mechanics to create unbreakable codes that cannot be intercepted without detection. Another area where quantum technologies can help is in extending the distance over which fiber optic communication can operate. As light travels through the fiber, it gradually loses energy and becomes weaker. Quantum repeaters can be used to amplify the signal without compromising its security, allowing for longer distances between communication and endpoints. Quantum key distributions. Now let's talk about quantum key distributions. Quantum key distributions, QKD, is a method of secure communication that relies on the principle of quantum mechanics. It works by using photons, particles of light, to create a shared secret key between two parties. The key is used to encrypt and decrypt messages, ensuring that only the intended recipient can read them. QKD offers several advantages over traditional encryption methods, including probable security and the inability of an eavesdropper to encrypt the keys without detection. While QKD is still in its earlier stages of development, it has the potential to revolutionize the way we think about secure communication. Quantum entanglement and quantum teleportation. Two other phenomena of quantum mechanics revolutionize that have the potential to improve fiber optic communication are entanglement and teleportation. Entanglement is a phenomena where two particles become linked in a such a way that their properties are correlated, even when separated by large distances. Teleportation, on other hand, is the process where the state of one particle can be transferred to other particle instantaneously, regardless of distance between them. While the concept may sound like science fiction, they have already been demonstrated in laboratory experiments. By harnessing the power of entanglement and teleportation, we may be able to create faster and more efficient communication systems that are not limited by the distances between endpoints. Quantum repeaters. As we mentioned earlier, one of limitations of fiber optics communication is distance over which it can operate. As light travels through the fiber, it gradually loses energy and becomes weaker, making it difficult to maintain a signal over long distances. Quantum repeaters are devices that can be used to amplify the signal without compromising its security. Quantum repeaters work by using entanglement pairs of photons to create a new pair of entanglement photons at a distant location. This allows the signal to be amplified without being intercepted or measured. While quantum repeaters are still in the experimental stage, they offer promising solution to the problems of distance limitations in fiber optic communications. Quantum memory. Another area where quantum technologies can improve fiber optic communication is development of quantum memory. Qua- Traditional quantum computer memory stores information as bits, which can either be 0 or 1. Quantum memory, on the other hand, uses qubits, which can be in multiple states simultaneously. This allows for much more efficient storage and rotational information. While quantum memory is still in its earlier stages of development, it has been potential to greatly increase the speed and efficiency communication systems. By using quantum memory, we may be able to store the process vast amount of data more quicker and secure than even before. Quantum noise and error correction. This is the last one, and after that we can conclude. In quantum communication systems, noise and error can significantly affect the reliability and accuracy of transmitting quantum information. Noise refers to an unwanted disturbance or fluctuations that corrupt the quantum states or operations involved in the communication process. These disturbances can be caused by various factors, such as environmental influences, imperfections in hardware, or even quantum effect themselves. The impact of noise and error or quantum can result in a phenomena called decoherence, where fragile quantum states loses their coherence and become indistinguishable for classical states. This leads to errors in quantum information processing and transmission. Conclusion. In conclusion, the use of quantum technologies offer a tantalizing glimpse into the future of fiber optic communication. By harnessing the principles of quantum mechanics, we can create faster, more secure, and more efficient communication systems that are not limited by distance or bandwidth. While many of these technologies are still in the experimental stage, the potential impact they could have on our daily lives is enormous. From secure online transactions to remote medical consultation, the possibilities are endless. So let's embrace the weird and wonderful world of quantum technologies and see let's how it takes. Thank you everyone and thank you for the time.